Well, let's talk about the mechanism of the deprotection of the first reaction, like the reaction we did before. Okay, so whenever we find the cellular ether, so this form of cellular ether, this one in yellow, we always use a source of fluorine. So we use a source of fluorine, for example, T buff tetrabutylaminium fluoride. So this one, 1 2 3 4. Here is the buff. Okay, 1 2 3 4, 1 2 3 4, and 1 2 3 4, and F minus. Okay, so a source of fluorine, fluorine atom, and we can also use HF. Okay, so because this atom loves silicium, okay, so it will attack it. It will attack the silicium. So how can we do this? Write the mechanism. We're just gonna use H plus F minus. Okay. Sorry, in having this molecule, so this protected alcohol, oops, not this one, SE, yeah, this protected alcohol is going to be attacked by the silicium, is going to be attacked by the fluorine atom, by the fluoride, and we're gonna have the alcohol, the alkylate in here, minus, and then we still have a hydrogen. So we have a hydrogen, then we're gonna grab it. Okay, so this alcohol is going to grab a hydrogen, you can say hydrolysis, and we form the alcohol. So we go back to the first molecule, this one. Okay, right now let's have a look at the deprotection of the second reaction. So the second reaction is going to be simple, like the deprotection. So whenever you see this benzyl, you need to use this reagent for the deprotection. Let me draw it in red. You need to use H2 PDC 10%. Okay, so what are you going to form? You're gonna form your OH, the starting molecule, and then you're gonna form a toluene. Okay, so form a toluene that we will have to use like rotary, like evaporator, to evaporate it. Okay, so yes. How about this one? How to deprotect this reaction? Let me just draw a red arrow. Sorry. So we need, like, it's the same. Whenever you see an acetal, okay? Whenever you see an acetal, remember, like, whenever, how can we deprotect this form? Sorry, let me just draw something else. For example, when we protect a ketone using this form of acetal, this is the same as this one. This is a cyclic acetal, and this is not cyclic, okay? Well, this is also cyclic, but, well, this one or this one, we did both. Like, we wrote the mechanism of both. So this is not cyclic. So how can we deprotect them? Like we just added H plus, okay? And when we say we add H plus, there is something else. There is a water molecule that attacks. Okay, so there is a water molecule, or we can add methanol to attack. Okay, so I'm going to use, in this case, we can use methanol. For example, let me just write a mechanism to keep it in your mind. For example, this is my molecule, my protected alcohol. So here I have, let me draw another oxygen here, and the other carbons. So the first thing we need to do is to grab like which oxygen is going to grab a hydrogen. So the oxygen that is going to grab a hydrogen is this one. Why? Because we need it to be a leaving group, like we need to get back our alcohol. So this oxygen is going to grab the hydrogen and form this, and form OH plus. Okay, so once we form the OH plus, we are having, let me just draw this better, sorry. So once we form this molecule, so we're having a good leaving group. So all of this is going to be a good leaving group. Let me just draw it again. All of this is going to be our leaving group. So how can we do it? We're just going to use to delocalize this one. Okay, we're going to make it like delocalize this lone pair, and then the alcohol is going to leave. So we form ROH alcohol plus this molecule. This molecule with, so the starting molecule, so this is an activated, sorry, not this. We form, let me just draw it a little bit better. Like this. We form this activated carbonyl compound. So if we're having methanol in the medium, we are going to attack. We're going to attack again and form a new protected alcohol. Okay, so and the reaction is going to continue. Okay, so so for acetals, the deprotection of acetals is going to require, so it requires acidic conditions. Okay, so it requires H plus, and sometimes when we write H plus, we mean that there is a possibility that a water molecule, like in the mechanism, we need a water molecule to attack, or methanol. Okay, so here the same thing, like there is another acetal group, so the same thing. And how about this one here, carbonate, a carbonate? How can we deprotonate a carbonate? It's quite the same. Like the first thing, we need a base. Okay, so we need a base, not very strong base. It's okay, like an carbonate, as carbonate, maybe carbonates, it works too. And we need methanol. So the base is going to react with the methanol to form methanolate, and then this charged molecule is going to act as a nucleophile and go and attack here. Like we're having a nucleophilic addition followed by an elimination. So what are we going to eliminate? We're going to eliminate the alcohol, so we're going to eliminate our starting molecule. So here is another way to deprotect the protected alcohol as when we protect it as a carbonate. Okay, so keep in mind, don't learn, just try to identify like the functions, and then identify how we could protect and deprotect. Okay, so how we could protect. So here we protected using a carbonate, so how can we deprotect? Always the same thing, using a base with an alcohol here the same thing we are having in acetal, so we need H plus with water molecule or methanol. Here the same thing in acetal, so the same H plus water molecule or methanol. And here benzene, whenever you see benzene, it's always this, okay? H2 PD carbon charb and 10%, okay? For ether, for cellular ether, just remember that fluorine loves, or fluorine atom loves silicium, okay? That's it.